So the GMT system, what is it that makes the GMT system so special? Well, one of the most important things that makes any turntable special is the method of drive. And in the GMT system, there are two key components that must be referred to in order to describe what it's about. So in this case, we have got the alpha drive and we have got the omega drive, the beginning and the end. Now, what are these two systems? The alpha drive is the computer-controlled amplifier which takes a quartz reference signal and delivers a three-phase power supply in order to drive the coils of the motor. There are 21 coils which are precision wound, and this is just one of them, on a 15-inch diameter chassis. And this is a synchronous motor, which means that the waveform that is delivered from the alpha drive is locking the rotational velocity of the motor. So the current and the accuracy of the current that comes from the alpha drive delivers a signal to the coils of the motor which creates synchronicity, and that is what gives it the speed stability. There are no feedback loops which are constantly hunting for speed. There are Hall sensors which monitor the system, but once it's in synchronicity, the rotational momentum and the 15-inch diameter of the drive is locked. So it's completely stable. And in fact, you can adjust it by 0.001 revolutions per minute remotely. The unique design of this motor is driven particularly by the gap. Now, what is it when I'm talking about the gap? Well, if we refer to the PAPS motor, which I have here, which was part of the old turntable that we used to make, you'll see there's a very small gap between the rotor and this stator, which is fixed in this case in the middle here. It's this small gap which improves the efficiency of all motors. The smaller the gap, the greater the efficiency. But of course, with that comes a price. The price is typically that you get cogging, because the interaction between the magnet and the coil induces a clicking sort of attraction. The greater the gap, the greater the reduction in that clicking, or that cogging as it's often referred to. So what we have in the Omega drive is a very large gap, an unusually large gap, which does make it very inefficient and also makes it very difficult to start. But once it's locked, the fluidity of the drive is the primary objective, and it stays perfectly in speed, and there is no cogging as a result of that design. So what we're trying to do then is we're trying to get a motor which drives with the utmost accuracy, but at the same time with none of these problems associated between with the interaction between the magnets and the coils of the stator. Of course, starting a motor like this is impossible. It will not happen because the forces are so small. The turning force on the motor is 0.00134 Newton meters. So in order to get the motor started, there is a computer in the alpha drive which kick-starts the motor into rotation, and then with a successive number of kicks gets it up to synchronicity. But once in synchronicity, the algorithm is no longer required. The motor just runs in perfect speed. So these are the principal features of the alpha and omega drive, which is a central facet of the success of the GMT system.